Welcome back, everybody. This is Opus Golden, and today I want to go over an additional item that we did not go over, and that's Authentik. So initially, we created an OAuth connection between Grafana and Authentik, and we found ways to prove and break Grafana. What about ways to break our IDP, which is Authentik? I actually found that there was a number of vulnerabilities that were just simple API calls that we can curl. And once you curl, you can run Python with. Whereas with Grafana, because of the image we downloaded, it downloaded with Alpine, it didn't have Python installed. With the image that we're utilizing with Authentik, that does have Python in the base image. So we can run curl and then a Python script underneath that. So one of the things we want to look at here is the architecture. This is our latest drawing that we have. And you'll notice here that we've secured up our Grafana environment. But now we have to think about our Authentik server. And one of the things I found within Authentik is that one has a metrics API that is basically running a Prometheus endpoint. In addition to their API calls for Blueprint, which is something that you can create expression policies on and then run it from your desktop. Of course, you have to have admin rights on there, but we're going to test and see what you could do with the Blueprint API. For now, we have a basic understanding of our complete architecture and maybe some of our goals that we're going to aim for. And what we can do now is try to see how we can utilize those attacks. So let's move forward. Okay, so our next finding, let's see if we can do a port scan. Okay, we just validated that 9000 and 9443 are wide open. 9000 is our unsecured connection, and then 9443 is our secure connection. So this is good for our first prove it. We just validated that every service inside that container is still binded. It's wide open. Even though these ports are closed, a bash misconfigure on that Docker compose file or just Docker run, and the possibilities of opening any one of these ports or 9300. Remember, we just did an API call out, right? For metrics. If this opens up, that metrics that we found earlier plays a part. So this is good. Okay, let's clear this up. Okay, so the next step is we want to see how our environment file is set up on Authentik. Are there secrets still being stored there? And in the end, we just want to see if we can even read them and what is exposed. And we can utilize that discovery. So from this, we're going to have to think like an auditor and not like an attacker. And we want to evaluate how our environment file is being utilized, and can we see the secrets in the environment file and what's in the environment file. So this is going to be a good exercise for us to see about what can we prove from going on there and how can it be broken. Let's just do a quick breakdown of what this is. So we're basically saying the owner has read write, the groups have read write, and everyone else has read. The owner is OLB and the group is OLB, which is always good. And it's horribly small. So the potential of finding an environment file there is very high. So from here, let's do a cat and then the environment. So we see the Postgres password and username. We see the secret. We see everything here. So from this vanilla setup, one of the things that we can take away from this finding is that the file is a world readable file. It is sitting in a user's directory. So we're finding out that one of the findings we have here is that one, the file is world readable. Everybody can read it. And it's in a user's directory. So first, let's clear this up. So next we need to get out of here. And we're now back to our jump box. Here's something that is very interesting that while I was doing the research is that Authentik has an expression policy engine. It basically allows admins to write Python code that gets evaluated on the server to make access decisions. Things like, is this user in this group? Or is it business hours? Useful feature, dangerous when an API is directly reachable. So now the goal here is we're going to prove that we can create a policy can contain arbitrary Python and execute it against that server. And the thing is that the server runs it in full Python context with access to the file system, environment variables, everything. So first we need to create environment variables before we get too far. So we got our IP. So first, one of the things we're going to do is we're going to generate a token. Yes, we could try to crack Authentik and generate a token, but for this and for the length of this episode, let's just create a token on the Authentik server and utilize that. So what this does is that we're basically going to run a Docker command within the Authentik container. And basically, AK shell is Authentik's management command that drops into Django Python shell. And basically, the -c is a flag passing a Python script directly instead of opening an interactive prompt. So basically, it's just going to forward in and bypass any prompts that would pop up. From here, from Authentik right here, and basically import token user and token intent, this basically imports the database models we need. Token is from the token table, users from the user table, and token intent is an enum that defines what a token is for, session, recovery, or API access. So the U equals user objects. Basically what this part does is that it's fetching the akadmin user object from the database, and hopefully we'll get a return of a matching record. And from here, we're basically asking to create a new token row in the database. The intent API is basically marks it as an API token rather than a session or recovery token. Identifier is a unique name. This is basically identifying it as a unique name. And expire false, it never expires. And of course, so this here is suppressing the verbose Django shell, and we just want to print out the token. Okay, here we go. There's our token that we can utilize for this exercise. Okay, we recorded it. Now we're going to clear this, and now we're going to go back to our jump box. We're going to create our environment variable to reference that token. All right. Okay. So the next thing we're going to do is we're going to verify the token. So from here, we're going to curl. We're going to run a curl silently, which is our S. We're going to utilize the environment variable, and then we're going to reach out and look for our API endpoint that returns the current authentication profile, which is we're validating the users here. If the token is valid, it will return a JSON with the user details. If it's invalid, it just returns a 403. And here we're identifying our token. Basically pipes the JSON response into Python. It allows it to be parsed cleanly and print just the username. We don't want the whole crap load of stuff to look at. We just care about the username, active status, and what type it is. Okay, so let's run it. Okay, key error here. Interesting. Okay. Okay, so now what we're going to do is just send this out without the without the garbage up here, and let's just see if even responses with the token. Okay, so we did. So it came in. All right, so we just validated the token works, and we got all of our information here. So this is good. Okay, so we got username akadmin, and is super users true. Something to note here. Yes, we did use akadmin to create the token, but it's really interesting always to see when a response comes back and it shows up as that it is a super user and what can be gleaned from this. In addition to, we can see that there's additional admins here. We have Grafana admin, we have Authentik admin, Bao admin. So this is really good stuff to take and record. So from this, we're going to look at creating an expression policy utilizing Python code that reads the secret key and the Postgres password from the container's environment. We are going to post it, and basically we're going to create a new expression policy via the API. So we're identifying policies and expressions here. the name's going to be F03 RCE probe. We're still utilizing this for finding 03. So the expression here is, this is the Python code that the server will execute. Importing OS reads two environment variables, which right here, and all this gets passed to AK message, which is Authentik's built-in function for returning output from policy executions. So make note of AK message, because that will be utilized many times over moving forward in this episode. And the response, so this is our UID, so this is good. Okay, so now we want to record, when you're doing this in your own home lab, record your UID here, because we're going to be utilizing this quite a few times. So next, let's clear this because we recorded them. So now that we have an expression policy, we're going to try to run some Python code on the server, and let's see what we get back. So what we have here is our API policy, right? We created this earlier. So what we're going to do here is that this UI, or API, is the policy test engine. This is the policy test endpoint. It takes the policy UID and a user ID and executes the policy as if that user's triggered it. So the good thing is that, so this is a legitimate API feature for testing policies. We're going to abuse it. That's the thing. Like sometimes you get these apps, and even though the intention is great, it can be abused. And in this case, we're going to try to abuse it to execute arbitrary code. And so user one here, this is basically utilizing our user ID 1. So this is basically AK message. Remember that AK message I mentioned earlier? This is the output that comes back in the messages array and of that response. We basically are looping through and print each one. So think of this. So think of the last part here as outputting our items from AK message, and we're going to print each of those messages out. If it works, hopefully we'll get a secret key, and a Postgres password. Man, look at that. So we're guessing that the top is our secret key and below is a Postgres password. And we're basically using nothing but curl and Python. So this is very cool. So this is actually pretty cool. So basically Django uses this for cryptographically signed session cookies. With this value, an attacker can forge a valid session key for any user in the system, including AKadmin. Postgres password, direct database access. Every user account, every session token, every seed, every OAuth 2 token stored in the database is now readable. This is great. This is the break part. Prove that we utilized the token, it was valid. So one, to create an expression policy, and from there we were able to reference that token in the UID, and we were able to pull the secret and the password, or Postgres password, from the Authentik server. Okay, so now that we've done this, we just did a prove and break. Let's clean up ourselves and let's delete the expression policy that we created just a minute ago. So basically this is saying a delete request to delete our expression policy from the policy UID. Hopefully we'll get a 204 or something that's 200 related. We got 204, very good. So now we're going to clear this up, and now we're ready to move on to our next vulnerability. Now we want to come back to prove it 7, and we want to see if we can break it now. So the first thing you want to do is make sure that token that we created is still valid. And it is. We got 200. So what we're going to do here, now that we validated that the variables are still valid, we're going to create an expression policy that does 3 things inside the server container. Our goal is to read the database password from the container's environment file. We want to open up a TCP socket to Postgres SQL container on our internal Docker network. And from there, we want to authenticate using the Scram SHA-256 protocol and run a SQL query to dump the user table. So all this happens server side. We send the policy, we execute it, and the results come back onto our jump box via AK message. And again, AK message pops up again. So what we're doing here is, again, we're creating an expression policy, and we're going to be utilizing our full Scrum SHA-256 authentication handshake, which is basically implemented in Python. So this is going to be the authentication protocol PostScript utilizes. And then from here, we're going to identify and read the database password here. And we're basically, the whole goal is to try to read this database directly within the container environment. We don't hard code it. We just let the container give it to us, which is really awesome. And so from here, we're also going to be sending a database command and querying the username, emails, and the types from the Authentik core and seeing what the results come back. So let's see what we get. And there's our UID. So now that we have this policy and we have this UID here, let's trigger it. Okay. So from here, we're gonna query the policy, and hopefully everything that we have set here, we're gonna utilize our SHA-256 or Scram SHA-256. We're gonna utilize the Postgres password, and we're going to run. Hopefully we get a user dump here. So let's see what we get. Oh, look at this. So we got a dump, a simple dump, but still a dump. Users, Sam. So everything is just like, you just gotta take out the first letter, or in this case, a few letters. But we know Dingo's in there. And we know that Sam's in there right here. So this is a good finding. So one of the things that can be taken away from this exercise is that, yes, we have used the API, but we queried the Postgres database in the backend using the credentials that we created earlier via finding 03 from within the container, using nothing but curl and Python. Fairly speaking, we bypass Authentik entirely. We ran everything through the API backend. Okay, so now let's delete our expression policy right here. Okay, and now we can, so we just proved and broke finding 03. And now we can move forward and look at finding 01, which is metrics endpoint. So now we can move on to our next vulnerability. So let's clear this up and let's get started. So the first thing we're going to do is jump on the Authentik box and see what is running on there. So we're confirming the containers, the image versions, and what ports are actually published externally. We can see here that Authentik is running on 2025 12.3. So this gives us a good foundation as to what we're trying to connect to. We're validating with this command that the environment file holds the Postgres database and the Authentik secret key. In addition to, we see that the permissions of the environment file is world readable. So this is not good. But as an attacker, this is really good. So next, let's clear this up. So one of the things that we have found is that if you create a token on the UI, we find that post operations fail. You'll get a 403 with no error message. So the goal here is to create a post token. In addition to, we want to find ways to harden our system, and by creating a API token on the UI, even though we are getting a 403, that does not mean that the container is hardened whatsoever. So that's the reason you see a token generation right here. There is our token. Okay, so we're now ready to do the exercise. So let's keep this token in our side pocket just in the future. So let's jump on to the jump box. So the first thing we're going to do here is create our environment variable for our token. Next, we're going to identify our Authentik IP. And now we're going to test and make sure that everything is verified. So we got a 200. We put the token and the IP together, and the response was 200. If this would have failed, it would have gone a 000. So our first vulnerability that we're going to try to find is our metrics endpoint. So here we're just trying to validate that the metrics endpoint exists, and then we'll build upon that. Maybe we hit the wrong URI. Okay, let's validate our port 9300 that we saw earlier. Let's see if it is reachable. So what we got here is that the metrics UI came back as a 401. Endpoint exists, but I think we require authentication. And the close, what we're seeing is that unauthenticated metrics is not reachable if it's not authenticated. All right, this is good. This is good. Okay, let's clear this up. Okay, so the next vulnerability, which is very intriguing. When I was doing my research this week, I found that Authentik has a blueprint system, which was a great find. I had to dink around and utilize Claude to find it and scour their documentation. But it's a YAML-based configuration management feature. The idea is legitimate and again useful. Like that's the one thing about Authentik. There are so many legitimate use cases for some of the features. It's just that some of it is very easy to abuse. So the whole idea about Blueprint is that administrators can define user groups, flows, providers, and policy as code and apply them repeatedly. Think of it like infrastructure as code, but for your identity provider. You write the YAML file, describe what you want to exist, you post it to the API, you hit apply, and Authentik creates or updates those objects. But the problem is with this, I don't know, I had to look and see if the newer versions of 2025 12.4 has limited this. But I know you can fix it via blocking some APIs via the reverse proxy. But the thing is that the API has no restrictions on what those blueprints can create. An attacker with a valid API token can post a blueprint that creates any object in the system. So at that point, once it posts a blueprint, Authentik processes that YAML and creates exactly what you asked for, with no additional confirmation, no secondary approval. The hard thing is not a bug. It's a feature being abused. It's easily abused. And we're going to show this in this episode. Okay, before we get too far ahead, let's make sure my token is still valid. It is. We got it to 100. Okay, so from here, we're going to try to exist all blueprints. We're basically going to confirm the endpoint is accessible and show us what is already installed. Interesting. Okay, so pagination is key instead of count. Interesting. Okay, that's fixed. All right, so from here, let's list all existing blueprints with the corrected response. Instead of this BS, we got this now, so we know what the query. Okay, so we're going to do all the same thing, but we know what blueprints there are. And let's see what we get. Oh, so there's 28 blueprints in the system already. Okay, so from here, so there's 28 blueprints. And okay, and this is vanilla. And so that means Authentik will process every single one here. Okay, so we just proved we can hit that blueprints API, and now let's see if we can find a way to break it. So what we need to do here, before we create our backdoor, we needed the UID of the Authentik admins group. Okay, let's do that. So let's clear, and then from here, we're going to do a curl, and we're going to hit here, we're going to basically going to search the group's endpoint for an admin group by name. And we're going to only print out anything that is classified as a super user. Okay, let's see what we get. So this is the UID for the Authentik admin group. So this, remember that we want to only print out anyone that is classified as a super user. And this UID is part of that admin group. Very cool. So we're going to create a blueprint containing a backdoor super user assigned to the Authentik admin group. Okay, so let's break this down. So version 1 is just basically the schema version. Entries is just basically list objects to create or update. We're first identifying the Authentik admin group, and we're going to utilize our WID here that we just found, and it assigns it to the internal ID admins group right here. And the username is going to be classified as backdoor. And so the key of admin group is to link all this to the super user group. So we're basically creating a username. Okay, so let's see if we can get our UID from this. Okay, we did. That's very good. So we're going to hit the blueprint API with the UID, and hopefully it's going to fire this whole blueprint, and we're going to be creating a new user called backdoor user with admin access. So our 200 came back. Last apply came back. And now we need to confirm the backdoor user was created and is a member to the Authentik admin group. So what we're doing here is that we're doing a search for any user called Backdoor, and hopefully we're going to be returning our full group object, including is super user. Okay, so the user has been created and it was put into the admin group here. Look at that. Okay, so this is very cool. All right, so we validated the user, we validated it was in the admin account, and we didn't have, and the cool thing is that we all did this via the backend Blueprint API. We didn't need to go through the UI. We just did everything in the back end. And the cool thing is that even though this user has been created, one of the cool, crazy things on top of all that is that state present. So what's particularly dangerous on top of the user and the admin account, this right here is very intriguing. This is persistence. What this means is that if an admin finds and deletes this backdoor user, reapplying the blueprint instantly recreates them. The blueprint itself is the persistent mechanism, not just the user. So everything that we create above here is the persistence. So deleting the user does jack. What you want to aim for is deleting that blueprint. And just the shoots and giggles is that we just clear this. And let's list all the blueprints. Okay. Okay, so our blueprint is not there. Okay, so I only listed 20 here. Maybe it is on a separate page. Maybe it's beyond 20. Let's search specifically for backdoor. Okay, there it is. There is our backdoor admin blueprint. Okay, so it is there, but you gotta search for it. So if it's beyond 20 blueprints, which in this case it is, it won't show if you show it by default. You gotta search for it specific. This is a good finding. Okay. So we just validated that we did prove that there is a blueprint API, and then we were able to create a blueprint utilizing the token that we created way earlier. And from that blueprint, we created a backdoor and we made it persistent so that even if the user is deleted, if the blueprint is still there, someone just has to fire it and it recreates that user all over again. Now let's do cleanup. Let's delete the backdoor user and the blueprint. We're going to delete our user here, the backdoor user, and then we're going to also delete our blueprint in the back end. And remember, you got to do both. You can't just delete user. You got to remember, I hate stressing this, you got to delete that blueprint. So now let's clear this up. And I think we're ready to go on to our next vulnerability. So our next vulnerability we're going to try to prove and then see if we can break it is to see if we can get our recovery key or our recovery code token. So the first thing we're going to do is we're going to go on to our Authentik server because we're testing everything out. So we need to we need to refresh and get a new token. Okay, here's our token. Let's record that. Okay, let's get out of our Authentik server. Let's clear this up. So now we're going to create our environment variables with the Authentik server as a variable and our key as a variable, or our token as a variable. So let's clear this up. And so one of the things that we want to review when we think about the recovery key is Authentik has a built-in recovery mechanism. Remember the AK messages? There's another mechanism as well. It's called AK create recovery key. This is designed for kind of like the administrators who get locked out. It generates a time-limited URL that logs you straight into any account with no password, no MFA, and no authentication flow. It's actually a legitimate feature, but like everything, anything that's legitimate can be used to break. The problem is it only requires a Docker execute access to the server container to generate. We were proven via previous vulnerability that we can execute arbitrary code inside that container from the jump box. So what we have here is we have our sub process, and basically what this is doing right here is that it runs an authentic management command inside the container. 5 is basically the minutes for it to expire, and the AK admin is the target account. All right, so now we're at a point. So let's fire this off. So we got our UID. We can reference that UID and fire this expression, and hopefully everything will work. So now that we got our policy created, now let's execute it. See, hitting the policies, we're going to execute the WID of the expression and utilizing our token. Okay, so this recovery token is good for 5 minutes. Okay, so we have our token here. So let's jump on to our jump box and let's try this out. Look at that. It didn't even have to log in. We logged in our admin account. Sweet. So let's talk about what just happened. Even though we created a refresh token on our Authentik box, we utilized that and basically create an expression, and we create a recovery key or recovery token expression policy, and then we hit that expression policy via the UID. And once that token was created, and we applied the token and used it, and we basically were able to log in without a password or MFA or nothing. We bypassed all of that because this is a recovery token or recovery key for anyone who has that URL with that token. For 5 minutes, they have complete access to the identity provider. Okay, so now that we validated the token works, let's kill it. Let's kill the policy. Okay, so we cleared that up. Okay, so then we clear this. So what we have found here through these findings is that, one, we validated that some API calls are good in nature, but in reality, they can be abused. In addition to, we've seen ways to display our secret key and our Postgres password, see the secret key and Postgres password. And we have found ways to, we also have found ways to log into the Authentik server from our jump host and run SQL queries because they have a Postgres SQLite backend. Have fixes for them, where that is moving the secret from the Authentik server to our secret vault, or putting a reverse proxy in front of Authentik and allowing that to handle our encrypted traffic and block certain API calls from coming in. In addition to, we can also lock down on how Authentik responds behind the reverse proxy by blocking all access to the Authentik server and only allowing the reverse proxy direct connection to the Authentik server. So within these fixes that we have discussed, we fix all the vulnerabilities and then we validate that those vulnerabilities are no longer there, either no longer there, fixed, or blocked. So until then, stay paranoid, keep an open mind, and continue learning. And I wish you well.